part two. So if you remember from the demo, we saw this barcode scanning part that was on the Raspberry Pi, and then we had this being published to a UI. So if you've been around a little bit in the Erlang Elixir community, you've probably noticed that the UI options have sucked a little bit, and fortunately they don't anymore. It's kind of funny because I feel like I'm sort of stealing Boyd's wind a wee bit because Boyd's been working on this over the last year. He felt that frustration of UI options in the Elixir and Erlang community, and so he solved this. So if you want to get all of this from first hand, please check out his conference talk that's been posted to YouTube. But I'd like to sort of give you a quick overview of it and talk about how we integrate this into our application. So a very quick overview. So Boyd's goal was to create a native UI library. And I guess the key thing is that he wanted to do something that would work on some sort of connected device. So the thing to keep in mind is this is really focused on fixed screen sizes right now. So if you're looking for something, it can certainly be used on the desktop, but if you want something that is like a really full-out desktop application, this is probably not the UI framework, but if you want something that is for a specific device, this is perfect. The cool thing about this is that the only dependencies is on Erlang and OpenGL. And so these UIs are really portable across devices. So he wanted something small. Obviously, when you're dealing with embedded software, smaller the better. Certainly robust if the UI crashes. You don't want your entire application to crash. Something that would work remote, so if someone's viewing that UI on one device, someone else would be able to remotely control that. He does a very cool demo of that. Obviously something secure, and from a development point of view, something approachable. So after doing a workshop at ElixirConf, and this is probably an excellent example. Hopefully I've got enough cord here without pulling that out. So again, here's a Raspberry Pi hooked up to a touch screen, but this is actually a Phoenix application that we've got running on here to produce the UI. It's integrated into the touch screen, so for example we can, and hopefully my fingers apparently aren't working tonight. Oh, there we go, okay. So we can dim the screen. We can write on there. That's an HTML canvas that we're doing, and from memory we are pushing that through sockets, right? Yeah, so we're using WebSockets to actually push the drawing through. But that's a pretty heavy-handed approach from a UI point of view, because we're having to throw Chromium on that firmware as well. So that's a pretty heavy-handed way to get a UI on there. So Boyd has provided an alternative for us. And so we've already seen that sort of demo, and we'll see some more examples of that as I go through. So, more high quality diagrams. Hold on to your seats. So the key things to think about the architecture of Scenic is that there's three components to it. One is scenes, that's the top layer, and that's typically where you're going to be writing all of your code. So you can kind of think of scene as a web page, and in that you are building a graph. And you can think of the graph as a DOM where you're adding elements to that graph. That graph gets pushed to the viewport. Typically you have one viewport per application, and that viewport will interact with a driver, and a driver will render the graph for you depending on what hardware you're on. So you can write scenes once, and depending on where you're deploying that to, you'll change the driver based on the hardware there. So, and the interesting thing is, I mentioned one of Boyd's goals was to have something robust. This is all built on OTP. So scenes are gen servers, they are processors, and so if one of those widgets, one of those scenes crash, it will do all the lovely things that OTP does and restart that, and it won't crash out the entire UI. So that's pretty cool. And a driver will, any data input, any input that comes from a device will be pushed up through the viewport and passed to the scene. So graphs going down, inputs are going up, 3 elements, scenes, viewport, and driver. So that's enough theory. Let's sort of see how this, see what this looks like. So I'm going to start off with a simple hello world that has a text and a button. Then we're going to view the kitchen sink that will look at all the different elements that you have available, and then we'll quickly look at our checkout application and how that's integrated with that. All right, so let's try the magic of, oh, got a screen here, and I need to mirror displays. Okay, that looks good. All right, so to save time, I'm not going to go ahead and generate a new application. If you've used Phoenix, it's very similar, where you'll add an archive to your Elixir installation, and you'll do a mix scenic.new. So that would feel very familiar. So I've already generated an application. I'm going to take you quickly through this, and we're going to add some elements. So this is our hello world. So to start off with, if we go to the config, there's going to be some terms that should be a little bit familiar by now. So we configure a viewport. As you can see, we can give that a name, size. The key thing here is that we specify a default scene. That's the scene that's going to be used when we start up. You'll see the second parameter here is nil. That allows you to provide any params to that scene. So if there's sort of any configuration there that you want to pass through. We've also talked about drivers. So we've got viewport, the scene, and here's the configuration for the driver. So we're all configured, and then we're going to jump into our first scene. So our first scene there, simple name, it's main. We are including the macro here, scenic.scene, that's going to turn this into a gen server for us. These have the init function. As I described previously, we talk about building a graph, and we push that graph to the viewport to be rendered by the driver. So as you can imagine by the number of elements in this one here, it's going to be pretty exciting, but at least it gets us started. And actually that's more than I thought we were going to have, because I didn't save the file. Because I'm actually in the wrong one. Let's change that. There we go. Okay, so mix scenic run will start the application for you, and holy moly, we have a blank window, but we can fix that. So let's start off with adding a text element. And so text elements in Scenic, hopefully I get this right, are actually primitives. So there's 2 types of, and I got that wrong. So there are 2 types of elements in Scenic. There are primitives, and then primitives are used to build out scenes. So we're going to add this to the graph. So basically, this is taking a very functional approach where you have a pipeline and you're adding elements to that graph. So with a bit of luck, this will work. Nope, got done wrong there. that should be pretty straightforward. I am, just in case I'm doing something really silly here.
Oh, you need components.
Yeah, but I thought text was actually a primitive. Wow. What is going on there? That is a little odd. Let's cheat here and...
Are you in the right folder?
I'm in starter, I'm in starter here, definitely in the right folder. I mean, it's saying that components is not used there.
The editor is in the experiments. The editor is in the experiments.
Yeah, yeah. So PWD, we're in experiments there. I mean, you can see that it compiled and it had the, you can see the unused, that is really not working. Okay, all right, so to go with the flow here, we are going to switch to the completed version of this, which is admittedly not too advanced, so we're going to continue on with that. So, hopefully, okay, that is very, very odd. I have no idea why that other one's not working. Okay, all right, we're just going to go with it. Okay, so we're going to go through some of these elements here. So you can see here that, hey, I've added a text element. I've added a button element. So text elements are primitives. Buttons and other elements are components. One of the goals, as I mentioned, was that this should have a familiar feel. So as an example here, if you've ever sort of done any HTML web programming, the concept of IDs, font size, should be reasonably familiar in terms of styling these. But of course, there's not much use in just painting elements on a page. You also want to interact with those. And so that is done essentially with sending messages through to the scene. So as an example, as an example, we have this is done by using a filter event. And here you can see we have a tuple that is listening to a click and specifying an ID. So on line 12 there, we have an ID of say hello button, and on line 18, we have a say hello button that we're going to be listening to for the click on. So when we get an event, we add to the graph or change the graph. So here you can see the event and the graph that's being passed through, and we are essentially just modifying the graph here. You can see that I'm referencing the ID, the say something that's used on line 11 there, and we're going to change the text to Hello Scenic. And then we're going to push that graph, and that will get passed to the viewport and rendered by the driver. So, let's see if that works. Okay. So that is the very basics of Scenic. So let's see a little bit more detail in terms of what the other elements look like. So when you generate a new Scenic app, it will actually include all of these widgets in for you, like this actual application that you can demo. So this is a sort of a very easy way to, I guess, get started. It's also annoying because if you're starting a new project, you've got a whole lot of junk in there as well. So let's do mixscenic.run and our kitchen sink. So here's a little bit of animation going on in terms of a splash screen. And so the first demo here is a sensor device where it's measuring the temperature. So you can imagine Raspberry Pi measuring, having a component for the temperature thermometer and pushing that information to this widget. So I talked about primitives. So here's all the primitives in terms of lines and shapes and text that we use, and those primitives are used to build out the components. And so, as Boyd said in his presentation, these components look very much like a bootstrap. That's not by accident. Again, it's sort of providing something that's very approachable to people that have done some web development. Yeah, so that will give you a bit of a feel in terms of the scope of the application. Of what Scenic provides you. And so let's have a quick look at how this is applied to our checkout application. Unfortunately, I won't be running any more code, so that should be easy. All right. So we have a checkout UI, which is separated, which is purely the UI, which is separated from our domain application checkout. So this should be familiar. Of course, we configure Scenic with the viewport, the size of the viewport, and the main and whatever scene that we want to start up with first. So actually, I should have, no, I'm sorry. So let's go to Scenic. So, I think that's what actually was probably missing from the other application. Did I define the viewport? Yeah, that's what was missing. So, and that's what was, this viewport's not there either. Okay, all right. Okay. Here we're just getting the info for the viewport, so we know what the width is, and we're doing some layout types of things here. So here we start off building the graph. We have some sort of the font sizes in terms of font and the font type. Now in the kitchen sink application, you'll see that there's just functions that continually adding text items and that type of thing. So it will be like all of these will be in the pipeline. That becomes really unreadable fast, and so sort of playing around with this, it became very natural to actually name those things. So as an example, we want to add a item list. Those were the prices that you saw. We want to add a total. That was, of course, the total you saw, and then a footer that contains the checkout button. So when you start structuring it this way, this actually becomes quite readable. If you were inlining these, and very much like any application you build, right? Create intention revealing functions, like it hides the noise of defining these text elements. We talked about filters in terms of responding to events. The thing that's different from the Hello World that we took a look at was this is actually responding to a message that's sent to it. So we're not doing anything necessarily different. We just have a callback function called handle info. So this refresh message is coming from our checkout domain application. And then we go ahead and display the data that we get. So we display the items, we display the total that we're getting from our checkout application. So how does it get that information? You can see here that we have in the checkout, we have a session that we subscribe to. If we go into our domain application for the checkout and look at the session in there, you can see our very exciting catalog here of 3 items. So these are our 3 references here, 1, 2, 3. We're just mapping them to money. We keep a list of subscribers in our checkout session, the list of items that have been scanned, and the total of that. Again, so this is just a gen server. And you can see here that we have a callback to handle the subscribe from our UI. And when we subscribe to the UI, we just add that to our list of subscribers. And we also, so when we start up, so this should be in our init function, you can see that we send ourselves a message to register. This will actually register to the barcode scanner on the Raspberry Pi. So this was the spawn link code that Hugo demonstrated in our previous presentation. And here you can see this is our scanned logic. So this is the notification that we're getting for when we get a scan from the Raspberry Pi, from the barcode scanner. And and so essentially, we've taken that ref code and we translate that to the catalog. And then we call refresh subscribers to push that information to the checkout UI. And we're doing a little bit of logic here where we're summing up items. And that's really it in terms of building a semi-distributed checkout system with Raspberry Pi using Nerves, and building out that UI using the new framework Scenic. So this code is available on our GitHub account, Civil Code. So if you want to sort of check out that and play with that. The README is a little rusty right now, so we'll work on that just to sort of make that onboarding process easier. But the rest of the code is ready to go. That's it. Any questions?